All right, I got good news. I finally got my Bluetooth to communicate with my dojigger, so the video should be a little bit, the sound, thank you. The audio should be a little bit better. Except, well, I'm supposed to have two of these, but evidently I don't rate but one. All right. What did we leave off with last time? Frequency distribution and class boundaries and all that good stuff, right? So let's put up a frequency distribution, and I want y'all to find everything you need to find with the frequency distribution. Just to make sure everybody can remember what we went over. Let's make ages. Let's see, 18 to 22. 18, 19, 20, 21, 22, that's class width. So 23, 24, 25, 26, 27, 28, 29, and 34, 38. 5, 7, 8, 6. All right, find everything you need to find. Class boundaries, class widths, label the lower class limit, the upper class limit, and be dispersed. Because you can't remember what we went over Thursday. When in doubt, what? Width. Sorry, you put it on, make it pop on and move it. Give up. The easiest thing to do. Right? Yellow day. 1, 2, 3. More yellow. Yellow is actually my favorite color. Yours too? Okay. Well, I'm not answering your question. What? 18 minus 23. Take the absolute value, or 23 minus 18. 29 minus 23. It shouldn't be. Did I mess up? Should be 5. Okay, this should be 28. I'm sorry. I must have missed. See, when you make a class distribution, if you count linearly, you mess up because you forget to count this. That's why I was counting in my head, and y'all were probably saying, he can't add 5. It's not that easy when you're going linearly. Linearly, hold on, I'll fix it. That needs to be 27. These should be 5. So that should be 27. This should be 28. 28, 29, 30, 31, 32. And this should be 33. Check it now. See if that's better. 33. 33, 34, 35, 36, 37. Check that. Is that better? Class width should be 5. You don't need a calculator. I heard a calculator go click, click, click. Why y'all got a calculator out? Y'all can't do second grade math? Well, put them up. I don't want you to be at that place over in the retail when somebody gives you $20 and 6 cents and you go, what is 6 cents for? Use your head. What's my lower class limits? 18, 23, 28, and 33. Upper class limits? The reason you don't need a calculator is because you find your first midpoint, 18, wait a minute, midpoint, 18 plus 22 divided by 2. Well, 18 plus 22 is what? 40. 40 divided by 2. And y'all need a calculator for that. And now what do you add? Add the class width, which is fine. 25, 30, 35. You're done.
So you don't use the 23?
23, where?
Like 18 and 23?
Yeah, 23 minus, well, it's supposed to be 5. 23 minus 18. What is 23 minus 18?
No, I meant for the midpoint.
Huh?
I meant for the midpoint. Like 18.
The midpoint, what is the midpoint? You can calculate each one if that's what you're asking. 23 plus 27 and divide by 2. 28 plus 32 divide by 2. 33 plus 37 divide by 2. Or you can find the first one and just add what? Class width. That's the easiest way to do it. Now let's do the boundaries. What are these? No, you don't. What are these? These are whole numbers, right? So our class boundaries is going to be to the 10th, which is to the 0.5. So 17.5. Now what do we add? Class width. What's 17 plus 5? And then you can just use your common sense. 22.5 plus 5 is 27.5. 27.5, 32.5, 32.5, and 37.5. Piece of cake. Okay, so you should have a couple of examples in your book now, your notebook on how to find all this stuff. And y'all will send me homework questions and we'll go over those. But that's not what I really wanted to go over today. I want to go ahead and talk about the mean and the standard deviation for frequency distribution. And let's see. And the reason I'm pulling this up is because they don't even show you the formula in the book. I don't know if they do now because they might have changed it. But last semester, the last book, they forgot to put the formula in the book. And I would have to pull it up on the homework because I didn't want to write it. So and I would pull it up. I'd go to one of the homework problems. Problem is I got to find out what section. I don't even know what section we in right now. 2.3. Does that sound right? Well, I think we just finished 2.2. Let me see where it starts talking about frequency distribution mean. No, that ain't it. I'll talk about that in a minute. That's not a big deal. It must be chapter 3. That's fine. We'll go to chapter 3 then. I want to cover it while we're covering this. I'll just go back and I'll just go to homework. Chapter 3, point 2. There we go. That's the mean. I must go into the, oh shoot, don't do that. Let's see, that's not what I want. Go to 3.3. There we go. All right, write that down. Write this problem down. This is a frequency distribution. It's just written this way. You can write it this way if you want to. The interval, that's your class. And then your head count is 2, 23, 42, 15. So write it if you want to in a, just like I did on the last problem. You don't have to write it this way. But that formula right there, and we're going to put the mean formula up in just a minute. That is the standard deviation. I would put the n inside here in front of that sigma. I wouldn't put it right here because some of you think you're supposed to take that n and multiply it by this whole thing. Don't do that. Put that n right here inside here so you multiply it by this number right here. Make sure you highlight, circle, the tab, color, whatever you want to, because you need to know how to do this because your idiot box can't do it. So you can't rely on it. It can do it, but you have to go through 15 different steps to do it. A lot of people say, I don't like the calculator. I love the calculator. I love to use it when you need to use it. But you don't know you need to use it to add numbers like 10 plus 16. And while you're doing that, I will pull up the other formula, which is summation of f times x over n. But I was going to pull it up on another.
Priority 1 message coming in on secured channel.
see, that was 3.2. There we go. And there, so you can write it down, is the mean formula.
The other one's standard deviation.
And we're going to talk about all of that today.
Priority 1 message coming in on secured channel.
Okay, so we've got two formulas. X bar or mu, whichever, doesn't matter, of the standard deviation is the summation of f times x over n. And that's what you got right there. Some people put summation of f or summation of f. Summation of f and n is the same thing. And n is how many people are in the room. So if you wanted to find the n, how would you find the n here? Add up all the heads. Frequency. Sorry. That's all it is, a head. So how many people are in that classroom? Well, 30 plus this, 44, 51, plus 7, 58. There's 58 people in that classroom. Same thing if I count you on here. Standard deviation is equal to n and times the summation of f times x quantity squared. Really? I thought I had it on here. Oh well. What happened to it? Okay, well we got that one written down. But the reason I wanted to do it on the board
Priority 1 message coming
is
in
because
on secured channel.
she's going to chew. I thought I had it up here. But I guess not. Y'all remember what number it was? No. There it is. F times x squared minus the summation of f times x quantity squared. Now, I'll tell students to write it like this. N times the summation of f times x squared. And if you want to put that in parentheses, that's good. Minus f summation of f times x quantity squared over n times n minus 1. In square root. Now the reason I want to write these down is I want you to be very familiar with them. I want you to dedicate an index card to both of them and put those two index cards somewhere on the front of your notebook. Because if I asked you to take the average and find the standard deviation of test scores, y'all can do that in your sleep. Alright? But this is what causes people the trouble with test. All right? Now, before we get into this, I just go to another page, flip the page over, we'll come back to this. What is standard deviation and all that good stuff? Well, in any kind of distribution, any kind of data, you want to know if it's typed or slopped. Now, some of y'all are going, what the heck is he talking about? Well, as you know, in today's standards, type means a lot of different things. Okay? We all know what the definitions of type are, but they all mean pretty much the same thing. If something is typed, it's right. Okay? Now, some of y'all are going,
Oh, I can't believe you said that.
well, from a mechanical point of view, anybody in here know what a bearing is?
Yeah.
Parents' ball.
It's a ball bearing.
Yeah.
Like a ball bearing.
Okay, a bearing. All right? I'm going to show you a picture of a bearing so you'll know. I know I'm not coaching you for a test in high school, so this is something you're going to need in real life. They're on your wheels on your car. Now, the reason I'm showing you this is because
Oh, you look good today, huh?
I know I always look good. Anyway, let me pull up. And I'm going to pull up bearing, housing, and axle. Or an axle. I don't know if that'll show up. There's a bearing. That's not what I'm looking for. Hold on just a second. Nah, that ain't what I'm looking for. Okay, well here's an example right here of slop. All right, a bearing is thought they would show a bearing somewhere. That's the bearing right there. A bearing is a piece of metal. It's actually two pieces of metal. Here we go. Of course, there it is right there. Let me blow it up a little bit for you. Now, the reason I'm showing you this is not because this is mechanical drawing 101. That's not why I'm showing you this. This is a bearing. It's made up of an inner race and an outer race, two pieces of metal. What's between the two pieces of metal? Ball bearings. Big old pieces. Now, roller bearings are little rollers. There's a ball bearing and then there's a roller. On your vehicle, you have either roller bearings or ball bearings, and there's usually two sets. One on the inside of your hub and one on the outside of your hub. When one of those goes out, your wheel falls off. Have you ever seen somebody when the wheel just falls off? I'm not talking about the tire. You ever been on the side of the interstate? I mean, not on you, but you ever seen somebody on the side of the interstate and they don't have a flat tire, their wheel just fell off? That's because the bearing went out. Your car is held up on bearings that cost about $3.49. And then go out at any time. Especially some of you people, I'm not talking to you people, I mean students, that go 110 miles an hour and think you can go speed of light. You got two things that can tear that car up. One the $3.49 bearing can go out and your wheel can fall off, or the 3/8" rubber brake line could break and you have no brakes. Now, why did I tell you that? Because a lot of people don't respect their cars. That's why. Anyway, now what goes in this bearing? A rod or an axle. All right? When you have a lot of slop in a bearing, it wasn't that funny. Well, where is it? I had it a while ago. I'm about ready to give up.
Zoom back out.
I did. I went by. Okay. Now, of course, that's not the axle that fits. What he's doing is he's pulling the bearing out of the bearing housing. This goes on like a piece of machinery, like a piece of farm equipment or whatever. There's the bearing. There's the housing. Here's a rod. Think of it as an axle. Why will this rod not work in that bearing? It's too small. What happens when you have a small axle or a bearing that's wore out? What happens? You get a lot of banging. You get a lot of metal on metal. And what happens? The bearing wallers out or the axle breaks. And that's called slop. Slop is when you have a lot of play. All right? What does that mean in your data? All over the place. Okay? It's not tight. Tight is when you have a bearing and the axle, you have to actually take a rubber hammer and you have to take like a socket and you have to tap the bearing onto the axle because of what? Some of you mechanical people. It's called, it starts with a T. O-L-E-R-A. Tolerance. Good job. Who said that? Good. You ever take a mechanical drawing? You haven't? Oh, because you don't like yellow, so I don't give you. All right, tolerance. Let's say a shaft is 2 inches in diameter. What's the tolerance on the bearing that fits on? 2.0000001 inch. So you have to take a hammer and actually tap put some grease on it and tap the bearing onto the shaft. Because if you don't, it's going to tear up in like 2 weeks. Why do you want your data tight? Because if your data is not tight, you're wasting time, and if you're working for somebody, they're what? Time and what? You get money and you get fired. All right? So, when you're talking about data, you're talking about it being tight. So, what does that mean? That means that there should not be any variation. You should have data that has a very small standard deviation. All right, let me show you what I'm talking about. Let's say you go out and take a poll of how many people in the parking lot drive a white car or something. It don't matter what the question is. And this is what you get. You got variation. You got data. Is it tight? No. It's all over the place. You got variation. High variation means slop. Go out and you get a whole lot more people. What is that? Tight data. In other words, you can draw a line and there's no variation. So this is what you want. You want something. Now, it does not have to be a correlation positive or a correlation negative. It doesn't have to be, you don't care about the correlation because then you're getting into bias. All right? To being biased if you worry about the correlation. But what you don't want is a lot of all over the place. Just think of a, you ever get one of the 25-cent bouncing balls out of the gumball machine and you throw it in and it just goes all over the place. That's what you don't want. Now, is there outliers? Yeah. 300-pound first grader. Yes. Throw them out. All right. Usually, what do your statistics teachers in high schools tell you? If you got something on the low end and something on the high end, what do you do with them?
Take them out.
Throw them out, and then you deal with what's in the middle, and that way your data stays tight. Now, what does that mean about standard deviation? Standard deviation here is going to be high. When the standard deviation is high, that means your data is sloppy. It means it's got a lot of variation in it. When your standard deviation is low, that means it's tight.
So the lower the standard deviation, the higher the frequency, the higher the standard deviation, the lower the frequency.
Not necessarily, because your frequency is your hit count. But you never want to, I don't want to, okay, I'm going to give everybody a project and it makes up half your grade and you need to go out and survey people and you go out and survey 200 and you go out and survey 5. His data ain't going to be worth crap. You never go with a little bit of data. You always go, and we'll get into that with classes in Unit 3, how to find if I want a 97% approval or that. I can't even think of the word right now. The 97th percentile, if I want a 97th percentile, then I need to figure out how many people to survey, and we do a formula, and we do that. And then that'll tell you how many people to survey. So, but yes, you've made a good, N is usually going to be high with your tight data. 5 people, it ain't worth even doing. And you brought up a good point, getting fired. Especially if you're going into marketing, you're going into business, you're going into economics, anything like that, where you got to give a report. I had to give reports, presidential reports, when I was department head. And if I went in there and I said something mathematically stupid, what would I look like? If I'm a math teacher, all right? Think of you, if you're handling thousands of dollars budgets, and you walk in and say, yeah, we found out that not many people smoke on the job, and the boss, the director or the boss, or he says, well, Michelin or whatever, said, how many people did you interview? 5? You're probably going to get fired right there because you wasted his time or her time, and you wasted the company's time because you were lazy. Okay? So that's why standard deviation is so important. Standard deviation tells you if your data is tight. What does the mean tell you? No problem. The mean tells you where center is. And that's why everybody wants to know what the class average is. But how do you do it? With a frequency distribution. Well, that's what we're fixing to do right now. So let's go back to our handy dandy problem. And we're going to find the mean and the standard deviation. Now, what is F? F is frequency. So you need to write that down. We're going to just label everything. F is your frequency. N is the summation of what? F. Well, then what would X be? It's not X bar, it's X. X is the midpoint. How did you know that? You're supposed to say, I knew it because I'm smart. X is your midpoint. Why do we need a midpoint? Well, how are you going to use that in the formula? How you gonna plug 20 to 26 in a formula?
Okay.
You can't, unless you want to do 6 calculations or 5 calculations. And it wouldn't be very valid. So what you do is whenever you're given a class, find its midpoint. X is equal to the midpoint. You need to highlight that because you don't forget. You know, y'all. I didn't know I was that bored. It's called Code Red. You get it in the store. I'm not a coffee drinker. I tried in the Marine Corps, and I tried when I attended Clemson. Clemson got spanked this weekend by them dogs. In South Carolina, got spanked by the Aggies. That quarterback for the Aggies.
Kenny Lewis is wrong.
I mean, he did real well. And dogs are going to be going down to Carolina when? Next week or this week?
2 weeks.
2 weeks. I don't know if that's going to be pretty. I don't know if that's going to be pretty or not. Who does Clemson play this week? South Carolina State. Well, as long as Clemson is not ranked in the top 10, they'll win. But they didn't win against Georgia. They gave that game to Georgia. I mean, they did. Georgia did good, and Gurley did real good. But
Who are you a fan of?
I love them all. I live in South Carolina, so I pull for South Carolina. I got 2 degrees from Clemson, so I pull for Clemson. And I always wanted to go to Georgia, and I live 8 miles from Hartville, so I've always wanted to go to Georgia, but I couldn't pay the out-of-state tuition, and I wasn't smart enough to get a scholarship, so I wanted to be a vet, believe it or not.
What school did your son go to? What school did your son go to?
McCoy's. It's called McLeese, but they don't call it that because that's too redneck. Just like Clemson, it's too redneck, so ESPN, they say Clemson. You ever notice that? You ever watch ESPN like game day when they come to Clemson? They won't say Clemson. They will not say Clemson because then they'll be the southern racist redneck. They have to say Clemson. So next time you watch ESPN game day, watch how they say Clemson. Because they will not put the P in. And everybody does that around here because it's Clemson. You know, you don't say Clemson. You sound retarded. And a lot of people say, oh my God, I can't believe he said retarded. Do you actually know what retarded means?
Nope.
Anybody?
Let's look it up.
Huh? Nope. What does the word retard mean? Somebody in here deal with engines?
Delay or hold back in terms of progress.
Exactly. It's out of time. The timing on your engine, you know what it's called when it's out of timing? It's retarded. Your timing is retarded. Oh my God, it said retarded. Before you be politically correct, make sure you know what your definition is. I wish they'd never used that word for impaired people because it's not right. They're not out of time. They're just different, unique. I have a nephew. He's autistic. And he puts all his toys in little places, and he's very smart. He can't talk to anybody, but he's autistic. But he's not that word. I wouldn't never use that word to him because he's very intelligent. Anyway, midpoint. I don't know how I got on that, but anyway, Clemson. Y'all gonna watch it now. You ever watch people pronounce QRSTUV? What comes after V? W. Watch next time somebody gives a web address. www. How many times have you ever said W? W.
You fool it.
W. DUB. Y-A-W. I'm sorry, I don't say W. I say W. Shut up and go back where you came from. Another word I will not pronounce is O-I-L. F-O-I-L. B-O-I-L. I will spell it out. I will not say it. Because I had a student. I'll tell you the story. To this day, I will not say F-O-I-L. I will not say it. Because I had a student. She was from Pennsylvania. The reason I say Pennsylvania, one of my favorite movies is Groundhog Day. Here we are in little town, Western Pennsylvania. Bill Murray gets aggravated. And I love that movie. I could watch it over and over. But anyway, intent to. Anyway, she was sitting right over in Miller Hall. She was sitting right about in that area right there. And she was about middle-aged, 40, 50 or somewhere in there, older son. And she was from Pennsylvania, and that's the way she said Pennsylvania. I'm from Pennsylvania, and I do not have an accent because I speak perfect English. People from Pennsylvania do not speak with an accent. Everybody else does because they are not speaking perfect English. And that's what she said. I had about 3 or 4 Bubbas and Bubbettes up here in this area. They were from Westo, Salem, Ivor, Southern Ivor, Loudville, where there is no crime rate. You know why there's no crime rate in those areas? They still hang people. They don't care what color you are. If you break into that house, they will shoot you. Or they will hang you and shoot you.
Oh, that's horrible.
I mean, it's rough. And yeah, anybody in here from Lounsville? Ooh, I wouldn't even be caught down there after 5 o'clock, and I'm backwoods, all right? Anyway, them people down there, they rough. Anyway, I have no idea what I was talking about. But anyway, what was I talking about? Oh yeah, she said, so the Bubbettes and the Bubbas with their knives on their holster right here, and their FFA shirts, and I was an FFA employee, so they had their own little deal going on right here. They thought she was funny at first, but then she started making fun of them. And she started making fun of me because I was right out of Clemson, and I wasn't refined and polished as I am now. Anyway, I talked as and I would say F-O-I-L the way that I say it, the way that I was raised to say it.
Oh.
How do you say it?
Oh.
Oh, F-O-O-L or F-O-L-E. Oh. And she would go, I knew as soon as I said it, oh my God, she needs to tone that hair down. She got that pompadour up here. Is that the girl that everybody's talking about? It's like up to here. Anyway.
I've never seen so many people jump up.
Anyway, it's about as high as his.
Oh.
I mean, honestly, but yours is, you do your thing when your hair, her hair didn't need to be that high. Her hair is like pompadour up here. Maybe it's a short thing. Anyway, so, I am talking, okay, we're going to do the F-O-I-L method, but I didn't say F-O-I-L method. And I knew, as soon as I said F-O-I-L the way I say it, I knew what she was going to do. She was going to make fun of me. Mr. McClure, I do not understand what you are saying. And the Bubette said, oh, I didn't say the whole word. That's what they said. And I said, I said, full. You know, full method. F-O-I-L, and I wrote on the board. Oh, I understand, Mr. McClure. You mean foil. And she had the nasal thing going on, and she had the Pennsylvania thing going on. Huh? Oh, I know. She was a jerk. She was a jerk. How long you lived in Pennsylvania?
About 5 years. I was
I have a good friend that's from Pennsylvania. And she married, and she says this, I married a Polak, and she is one of the nicest people, got the biggest heart in the world, but she says that that woman was a jerk. Anyway, she was, and she ran out crying because everybody was laughing. And they didn't stop laughing, and I just sat down and just
Kind of laughed along.
I just waited until everybody started laughing. And then the Bubbas and Bubettes that were sitting up here, they were saying, would you like a piece of foil, please? I would like a quart of foil, please. She ran out, crying. Her book sat there for 2 or 3 days. Finally, somebody came and got them. She never did drop the class. So what did I give her? Big old F, because she knew to take the test. Only F I ever gave that I really enjoyed. That's a prime example of dishing it out, but what? Can't take it. She was a real jerk. And to this day, I will not say F-O-I-L or O-I-L. Even at my home, I won't. I've done got used to doing it. So when my kids do it now, my kids will say, Daddy, we need to check the O-I-L. I said, okay, let's check it. So that's my 7-year-old. He loves mechanical stuff. But anyway, let's get back to what we're talking about. I have no idea how we got there. But anyway, Clemson. Clemson, O-I-L, and W. Now, let's go ahead and find the midpoint. And I tell you what I want to do. I want to pull up the spreadsheet. Because it's a whole lot easier to show you this on a spreadsheet. And you can see everything. So if you want to draw a spreadsheet, that's fine on your notebook. A spreadsheet, Excel. Now, what I'm going to do, I'm going to show y'all a trick I learned in the war. That's a joke. You see this little do-jigger right here? See that right there? Click on that. And copy. Okay. Then I'll take the Excel spreadsheet. Then I'll hit Control-V. Saves you a lot of time. Now, you can't use these numbers. Why? Because they're not in what? They're not in the, you don't have the midpoint. So, what I tell students to do is do this. 20, 26, 27, 33, 34, 40, 41, 47, 48, 54, and 55, 61. Now, some of you Excel people, why did I do that?
Because you can't have 2 numbers.
Exactly. If you can't have 2 numbers in a cell, you can't calculate them. So now I can calculate my midpoint and call it X right here. Now, a lot of people, let me go ahead and throw out a disclaimer. On video and capture, just because I'm using Excel, don't go home and say, I gotta use Excel. I gotta use Excel. I'm only doing it on Excel because I don't want to have to draw all these lines on the board. That's the only reason I'm using it. If you want to use Excel, go for it. All right? And I have been known to make these things up and send them to you via email, if you remind me. So midpoint. How do I find my midpoint? Well, equals, parentheses. I'm going to put in a mathematical formula. What am I going to do? I'm going to add this guy, plus 26, close parentheses, divide by 2, and then watch this. This trick learned in the war. And there's all your midpoints.
Can you explain what you did, like, on the keyboard to make that happen?
I just,
No, to divide everything.
right there. There it is. The trick I learned in the war is a joke. Somebody said, what do you do in the war with Excel? Shut up.
You go to the war?
Yeah.
You go? Did you ever kill anybody?
Locked and loaded on some Iraqis, but all they wanted was food. All they wanted, we gave them like 2 MREs and they ate the whole thing, just like in one sitting. All right, now what do we need? Midpoint. We've got our frequency.
Lower class, upper class.
No, we don't need that. I'm talking about for our mean and our standard deviation.
Oh, the total number.
Need N, right? So we go down here to the frequency and say N is equal to And what do we do to these guys? Hit the summation key and add all those up. And there's your frequency.
This is good.
I'm fantastic.
You are. It's correct.
All right, now we've got everything we need. We got to go back to our formula because we need to know what to do. What does that say?
Multiply.
F times what?
X squared.
So we've got F. So we need a column called what?
X.
X squared. Equals this guy raised shift 6 to the second power. Yep. Now what? Well, we got to multiply F times X squared, don't we? I'm going to call this F because I don't like that. There. And this upper class limit and lower class limit. So I'm going to go over here. I'm going to skip a column because I don't want you to get confused. So we're going to do F times X squared. And that's going to be equal to F times X squared. And then what else do we need? We need F times X. So we go over here and make it F times X. Equals
You just take the square
F.
root of that, right?
times, no, better not think like that because you'll end up getting messed up, times X. And then what are we going to need of those two? Summation, Hubert. All right, so what do we have?
Priority 1 message coming in on secure
Is equal
channel.
to, what's in? Times, what's F times X squared summation? 155, 761? Minus? What's F times X summation?
38.45.
And what do we do to that 38.45?
Square it.
And all that over 99 times
98.
and we're going to do that. I want y'all to do it on your calculators. And you know what's so good about this? Once you do one of these, you save it. And then when you get to the test, you pull it up and you just copy and paste the numbers in and it does it for you. Unless you just like to do things over and over and over.
What'd you get? Did you get that?
Well, I'm going to go down here and do it for you.
Sounds good.
But I'm going to draw everything out. Equals 99 times equals this guy. And I'm going to put minus this guy. And raised to the second power over, I'm not doing the calculation, I'm just putting it just like I did up there, over equals n times equals n minus 1. Now there's the numbers you got to work. So now I'm going to go down here and I'm going to say equals this guy times this guy minus equals this guy raised to the what? Second power. Should this number always be smaller than this number? Why? Because you can't take square root of what? Of a negative. Equals 99 times 98. So that's what your number should be right there. Equals this minus this divided by this. And that's going to give us the variance, which we don't need. This divided by this. And that's our variance. Now your variance is not very important, so don't worry about it. But if you want to find your standard deviation, take the square root of the what? So standard deviation is equal to SQ RT, or just take equals this raised to the 0.5 power, and there is your standard deviation. But it's useless because we don't have the mean. So what is the mean? The summation of f times x, the main. The summation of f times x. Where is the summation of f times x? Right here, Hubert. Thank you, class. Divided by what? And there's your mean. Now, write those two numbers down. Right there. We're going to paint them green. Why are we painting them green? Because they're important. Very important.
Are you going to put this somewhere?
No. I'm going to erase it as soon as I get through with it.
Appreciate it.
All right. Now I'm going to show you what this means. Now I'm going to make it 39 and 8 because I don't want to deal with the decimals. Okay. Now watch what happens. What's 39 plus 8? What's 47 plus 8? I don't know. I mean, 55 is 55. Yeah. I don't know where 80 has 5 came from. I suck. 55. Check those. What's 39 minus 8?
31.
What's 31 minus 8? I guess. And there is your standard deviation and mean. So you just formed your normal distribution. And you did it for a frequency distribution instead of test scores. Test scores will be like 25, 26, 23, 24, and then you add them up, divide by, and we're going to do that tomorrow, which means, yeah, Thursday. Okay? Everybody knows how to do that, but I wanted to spend more time on this because some of you have never seen this before. And y'all now feel good about yourself.